Share screen. Okie dokie. So last time we were talking about nested queries. We talked about the few operations, right, or few keywords. So any, all, in, and exists, yeah, which are used in nested queries. So typically you have an outer query, and then which is a select statement, and inside of it you could have another select statement in the where clause. So we looked at a lot of examples on our TOEI database, which is the mother-child, father-child in person. Okay, now today we're going to talk about using these nested queries and insert, update, and delete statements. So they can also be nested, and that's really one of the very popular use cases of nested querying. Okay, so the upper query is typically an insert, update, or delete statement, and the inner query is a select statement. And the same rules of nested select queries applies here. So, right, basically every the nested query is executed for every tuple in the outer query, and right, you can refer to an outer something, a table from the outer query in the inner query, but not vice versa, and so on. Okay, let's look at an example. Let's say I want to combine the data in father-child and mother-child in the table father-child. So I want to have a table, one table, which contains the information of all mothers and fathers. So basically for every person, who's the mom and who's the dad, in just one table. Right now we have it in two separate tables. If you look at the schema or database, we have the following. We have father-child has, right, for every person who's the dad, if this information exists. And then you have another table, mother-child, which has the information about the moms. Yeah, so Mary, her mom is Lisa, Greg, his mom is Lisa, and so on. Okay, so let's say I want to combine this data into one table, the father-child table. So I can go here and say insert into father-child, select asterisk. Okay, so basically I'm saying now take whatever is in mother-child and put it into the table father-child. Let's see if I execute this query, what happens. I get, right, 6 rows inserted. This is how much time the query took. And if I look now at the table father-child, what do I expect to see? I expect to see information about the moms as well. So now I have father and child.
Sir,
yes.
What if the mother-child has more attributes, like columns?
Then it wouldn't work, right? So you have to have, if I'm inserting something, it has to follow the same, as if you were saying insert into table, and then you have, right, a set of explicit records. So it has to match the scheme, correct? Otherwise it wouldn't work. It will give you an error.
Okay, but it could have less attributes, right?
If it have more attributes, you can select the attributes you want to insert. So here in the select statement, I can say, right, so where's the select statement we used? So it was insert. I'm not going to execute it again, but into father-child, I could specify father and mother, father and child, and then select mother from select mother, comma, child from mother, child, right? So I could explicitly say which attributes I want to select from the table mother-child. Let's say mother-child had more information. I could say select only the mother and child, and then insert it into father-child of in this order, father and child. Yeah, but since they had the same schema, I could say just insert into father-child, select asterisk from mother-child. Yeah, but I could also specify which attributes exactly I want
Okay, thank
in which particular order. Okay. Good. So if I look at the query, it's insert into father child. I don't have to specify here father comma child because it will take if I say insert into father child as we executed it in my SQL, select star from mother child, it will do exactly the same thing as in this query. Yeah, this is explicitly saying the attribute names, but I could also skip that because they have the same scheme. And the order is the same. So first the father, then the child, and the table mother-child, first the mother, then the child. Other questions? Okay. I can also do an update statement with nested querying. This is really useful. So this is what you tend to do in practice a lot because you have your data and then you want to augment it or update it in batch mode. So really, you want to update based on other information in other tables. So here's an example, right? I want to give raise to all moms because it's Mother's Day. So Mother's Day was just recent, 21st of March. And I want to give a raise to the moms by 1%. Okay, so first of all, so I want to go to this table person and then only for the moms. So basically, right, if Anne is a mom or Lisa is a mom or Mary is a mom, then her salary should be increased by 1%. Yeah, so not everybody, only moms. So which table I want to update? I want to update the table person. So update person. So that's updating the table person. What do I want to update? I want to update the salary, the income. Set income equal to income plus income times 0.1, right? 0.01, right? I want to do just 1%. So 0.01. Okay, if I execute this query, this will update everybody, the income of everybody in the table. But I want only those guys who happen to be moms. So I have to do a where condition, right? Where name in, for instance, select mother. So I'm saying now don't update every record or every tuple in the table person, update only those who happen to be mothers. So how do I get to the people who are mothers? They just basically, if you select mother from mother child. Okay. So let's run this query. And you get to see that you have, okay, it says one row affected. It should be more than one row. So we'll see why this is the case. Okay. So let's see the table person first and see if it really affected only one row. Okay. Yeah. So what was the original things? Let's see. So Mary was 42. It's still 42. Okay. Kim was 41. Kim is 41. So Kim is not a mom, right? So basically shouldn't update her. So Lisa, Anne, and Mary, we want to update the income of Lisa, Anne, and Mary. So let's see, Lisa was 87. Her income is 87. Lisa, her income now is 88. Yeah. Now Anne, her income was 35. It should have increased. It did not increase, right? And Mary, her income is how much? 42. It should have increased, but it did not, right? So it seems it only increased the income of who? Of Lisa. Yeah. So let's see again the query. Here's the query.
Sir, I guess because they are rounding, so when they are rounding ما بتتغير بتصير 42.4 so عم بترد على 42.
It could be because this is an integer, but let's see. Let's try it in a different way. Let's test your hypothesis, right? So I'm gonna update person. Update person. Set income equal to, let's say, 90, right? So fixed, right? Make it 90 for all of them. Where and select from mother child. Just to see what happens here. Query box, then go, and then here you see 3 rows select, updated. So it seems you're right, yeah, because the column income was integer, so it rounded it, so it didn't update except 1 row, yeah. So if we look now at the person, good theory. So it seems it's correct. You see now that Lisa has 90, Mary has 90, and has 90. Yeah, so it updated the income of the moms. In the previous one, just because of the rounding, did not manage to update 2 of the rows. It is clear to everyone, but the semantics work, right? I'm updating person, setting income equal to income, let's say plus 10%, that would be 0.1 times income. That would update all of them. Where name, first thing is the selection here, where name and select mother from mother child. All right? Good. Questions? Good. Let's see the following update. I want to update the income of all mothers to the maximum income of their children. So I want to see for every mom, what is the maximum income of her child out of all her children? What is the maximum income of her children? And then update the income of the mom with this maximum income of the children. So I can do this using the following select statement. So I'm saying update person, set income equal to, select maximum of the child income from person, mother child. So I join person and mother child to get the income of the maximum income of the child, right? Where c.name is equal to mc.child. So I'm joining such that the person is a copy of the children. Yeah. 1 second. And mc.mother is equal to m.name. So the inner query just selects maximum income for every of the children of every mom. Yeah. And then I update the person, setting the mother's income to this maximum income. Couldn't we have joined person and mother child on person equal mother instead of nested query? So how do I get them? I want to do 2 things, Mira. I want to update the income of the mom, and I want to get the maximum income of her children. So the maximum income of her children is this blue query, the inner query. Yeah. So this just selects maximum income of a child, or of the children of a given mom. So a given mom here, select her the maximum income for her children. That's why I needed to do a join between the table mother, child, and person. Now, once I do this, I need to update the income of the mom with this maximum value. So I need a nested query to do the update. This is clear? How am I going to do the update without a nested query? This is not clear to me. Yeah, I can get the information with the maximum income of a given mom using a join, but the idea is that I want for every mom get the maximum income of her children and then update her income with that value. I hope this is clear now. Okay. Sorry. Let me see.
Professor Hishimant asking about the previous example.
The previous example. Okay, so the previous example, which was this. How do I update the income of a person? Yeah, so I have the way to update an income of a person is to say update person, the table person, set income equal to the new value. Yeah, so now if I do this alone without any nested querying, this will update everybody. And I can update a join. A join is just a select statement. So basically, I will get tuples that are joined from two tables. But how do I update? I really need a nested query. There's no other way to do it. Does that make sense? Okay, good. Okay, so now this is to do the update. Let's ignore the where exists for a second. Yeah, so let's just run this query without the where clause. Okay. So I'm gonna do update person m. I give it an alias m, set income or m.income in that case to be specific, equal to select maximum of child.income from person C, mother child MC, where C.name is equal to MC.child. So I'm copying, right? The person C is the representing the children. Okay, and child and MC.mother is equal to M dot. So basically, what happens is I go over every row in the table person and I set the income of this person to the maximum income of the children, yeah, of this person. Okay, let's execute this query and see what do we get. I'm gonna copy it. Before we execute it, let's look at the table, the results in the table that we have control C. And let's see the table person. Right, these are the incomes of everybody. So I have 21 for Andy and 90 and so on. Now I want to update the income of Anne to the maximum income of her children. Let's see whose her children are and then get their maximum income and update Anne's income with that maximum value. Okay, so let's execute the query. Okay. Okie dokie, and then we say go. We have an error. You can't specify target table M for update in the from clause. Okay. So it seems it's complaining.
I guess كتبت MC. لا ما فيش.
لا ما فيش. هو هنا is complaining here, right? I don't understand why it's complaining. Till update person M, set M.income. Where is that? Okay. Should semicolon, where semicolon, no, doesn't matter, right? So it wouldn't make a difference, yeah? It's somehow not accepting the fact that I'm using an alias in an update statement, yeah? So it could be that MySQL doesn't support this. And the problem is we can't do this without the aliasing because I need it here. If I do this, it will get confused. Which name am I talking about? So if I try it like this, it will complete. Yeah. Cannot specify target table person for update. Ah, okay, I see. It's this. It's because I'm updating and selecting from the same table as well, right? So it seems this is not working in MySQL because here I'm saying update the same table person and I'm selecting from the same table person. Yeah, but in standard SQL it should work. So it might work in SQL Server or in other, right, database management systems. Yeah, so it might not work. So MySQL does not allow you to update a table and refer to it in the same statement. So this would not be possible. Okay. But the semantics of the query should be clear. Yeah. So unfortunately, I cannot execute it here to demonstrate the results. But this is in standard SQL should work. Yeah. So update person m. So just a side note that in MySQL there are certain things that are not implemented. For instance, the full outer join is not implemented as well. So you have to do, right? You can do a full outer join in MySQL, even though it's supported by the standard SQL language. So the language is separate from the implementations in different database management systems. Some database management systems support certain things and some do not. Okay. So let's just look at the slide, yeah, for this one. So I'm updating person, as I said, right? Selecting the maximum income of the children of this person. And then I'm adding this where exists clause. So why do I need this? If I don't include this, this will update every record of the table person to the maximum income of the children. And if there is no child for a certain person, so all the fathers, for instance, or all the people who do not parents, the select of maximum income would return a null value. Yeah, because basically there are no children. So this would return a null value. And I will update the income of the person that is not a mom to null value. So the where exists is crucial here. Otherwise, the income of all non-mothers will be updated to null, since the inner select statement will return null for all persons who are not in the mother-child table.
Exists or exits?
It exists. Yeah. So this is a type. Exists.
Okay.
Yeah. Okay. So unfortunately, again, right, this we cannot execute in MySQL. Okay, but I hope you get the idea of using nested queries and update, select, and delete statements. Okay, let's say, for instance, I want to delete, as a last example, all people that do not have any children. I want to delete from the table person where name not in. So anybody that is not a mom, right, or a dad should be deleted. So what do I do? Select mother from mother child. Okay, so that would delete all the people who are not moms. And not in. Okay. Why and? Because I don't want to delete somebody who's somebody who's not a mother and a father. Yeah, so that's why I need to, so only people who are not a moms and dads. Yeah, so that's why I do an add. To delete person when name not in, select mother from mother child, and name not in, select father from father child. Okay, let's do a go. Again, we have an error. Is the error? Yeah, probably. Yeah. Delete from person. Correct. Let's see. Yeah. So here we have a. Who can tell me what is this error? It's because of the foreign key, right? So when we created a foreign key, so we have a foreign key. We have a foreign key, integrity, referential integrity constraint, exactly, yeah? So delete from person. So because we didn't specify, right, that you cascade or set to null, so it causes, right, a referential integrity constraint, and we can't delete, right, from the table person because it's referenced and by the table, the table father child and mother child. Yeah. So if I have to drop either the constraint or make it right cascade or on delete set null. Yeah. So we did it on delete restrict, but if I want to execute this query, I will have to change the action taken on delete for the foreign key constraint. Okay. Good. So right. So basically it says foreign key, the child references person of name. So if you're trying to delete, right, a record, it might cause the child constraint to fail. Yeah, because child is pointing to person. Questions? Okay. Very good. So what we're going to do now is we're going to do views, and then we're going to do some exercises on nested querying in general. Okay. So views. We have how many minutes? We have 10 minutes left? Okay, good. Okay, so we talked last time, right? So basically until earlier today, we talked about set operations and nested querying. I think you're now experts in this. We're gonna talk later today about something called views. Very cool concept in SQL. So again, we're gonna play with the same schema, the database schema that we've been playing with. So father, child, mother, child, and person. Here is what caused the delete statement to fail. This child foreign constraint to the table person. So if we're trying to delete a record, right, a person that is not a father, for instance, but is pointed to, right, by this foreign key constraint, it caused the issue, right, the failure of the delete statement. So I have to either make this, you know, either set null or cascade, delete the record that references any record that I'm going to delete. Okay. It's again the results in the database, the tuples in the database. Now, what is a view? It's a dynamic virtual table derived from the data in the database, i.e. it's not a table, it's not physically stored, it's nothing more than a select statement, but I save the select statement. So I write a select statement and I save its results. Remember that select statements are nothing but temporary tables that I see. And as soon as I execute the query, I see the results, and that's it. They're gone. They're not materialized in the database. So views allows you to save the results of an SQL statement. Save it, meaning what? Meaning that I can refer to this select statement as if it's a table, but it's not really stored in the database. Yeah, so it saves as if it saves the SQL statement and executes it each time you refer to this select statement, to this view. So views are used for the following purposes. It makes you be able to represent a subset of the data contained in a table. So I have a large table. I typically want to only work on a subset of the attributes or the data in this table. So either rows or columns or both, right? So subset of the data, I can store it in a view or refer to it as a view and be able to use it as if it's a table in my database. It's usually used to join and simplify multiple tables into a single virtual table. So basically, instead of writing very complex select statements, I can do joins and simplification of multiple tables and refer to this as a view and use it as if it's another table in my database. I use it to aggregate tables, so I can write aggregate tables using a select statement with grouping, etc., and then save this as a view. What's more important, and that's the real main reason for using views, is that it gives you data abstraction. So meaning what? It allows you to abstract the data in the database. Some data are not accessible to everybody. So it provides basically extra security and limit exposure to a table or a set of tables. So I have my database. Let's say I have, it's a university database, and I have, grades, I have courses and enrollments and so on. So I want information about professors, salaries, etc. So now I can use views to abstract the data and give access to different people based on to different parts of the database based on their privileges. So students are allowed to only see their grades, their courses they're enrolled in, times, schedules for the courses, who's teaching the course, and so on. But they're not allowed to see salaries of professors. They're not allowed to update their grades, and so on. Yeah, so it allows you to abstract things and break the database into chunks such that different people have different access rights on these chunks. So it's very useful in a realistic database. I encourage you to use it in your project, yeah, to kind of abstract things and allow you to give different privileges to different types of users. Let's see, and how do I do this? So the SQL statement to declare a view, yeah, to basically create a view in your database is create view. You give it a name as, and then you give it the query, the select statement that is gonna be the base for the view. Once I create a view, I can use it in other statements as if it's a real table, yeah, as if it's a base table that is in the database. It's not a table, it's not materialized, the results are not stored anywhere on this, but it acts as if it's a table. So from the point of view of the user, it's as if it's on any other table in the database. Let's see an example. Let's say I want to create a view that contains all the information about people who have no children, okay? So I'm gonna do the following. I'm gonna say create view, and I'm gonna call it single as. Select name, age, and income. That's the information of people. From person P, where not exists. Select asterisk from father child, where name is equal to father, and not exists, select asterisk from mother child, where name is equal to mother. Yeah, or select, right, basically name, age, and income from person, where name not in, select father from father child, and select mother from mother child. Yeah. So let's run this create this view and then see what it means in detail. So I'm gonna go here. I'm gonna say create view single as select Asterisk from person. So I'm going to change a little bit the query, write it in a different way. Yeah, select asterisk from person, where name in, not in. Right. Select father from father child. So basically, I want to get all the people who are not fathers and not mothers. Name not in. Mother. So this select statement, if I just run this select statement, will do what? It will get me the information of all the people, so name, age, and income of every person that is not a father and not a mother. Now I'm saying save this query as a view called single. Okay, so let's execute this query. Okay. And it did something, yeah? We don't know exactly what it did, but I can refresh now. And I see something called views. So now it showed me tables here on the right, it showed me tables on the left, sorry, and something called views. So now I have something called single view. And this single view contains basically information about people who are not parents. So Andy, Kim, Mike, Phil, and Rob, right? Because these are not the parents in the database. If we look at the database, sorry, not this one. Here is right. Andy is not a father. Rob is not a father, right? Mary is a mom, so it's excluded. Anne is a mom, is excluded. Phil is not a father, so it's included. And Kim is not a mom, so she's included, okay? So you see, here I have Andy, Kim, Mike, Phil, and Rob. Okay, is this a table? So what is the difference between single and father child, mother child, or person? Single is not a table. It's not anywhere in the actual disk, hard disk. Yeah, it's basically a view. So every time I refer to this view, what happens is the SQL query is going to be executed. 1 second. Yeah, so I have a few questions. 1 minute left. Okay. So I'm gonna, we're gonna end the meeting, and then please join the link again, the same link again. I will start it and we join the same link again. Okay? Good. And I'll repeat this last thing again. Okay. So end meeting, and then use the same link to join the meeting again.